Greetings, scholars! I am so happy to be making this video for you. First thing is, I have scratches all over. I was doing gardening and shoved my hands in bushes, so sorry about that. Second thing is, sorry this is late. I filmed about 5 videos until I realized that my microphone was off. So again, I had a bunch of videos with 0 audio. So let's get started. The very first thing that I'd like for you to remember is how to graph displacement or let's say linear motion. Okay, I'm going to make this as short and sweet as I can. Imagine that you are in your car and you're in your driveway, or let's say you're in your garage. You go ahead and drive away from your house. Okay, and you stop at the stoplight. Then let's say that you realize you forgot your wallet, so you very quickly completely reverse. You back up. Let's look at what this looks like on the velocity graph. All right, so initially I take the slope of this line and put it here. Let's say that this looks like a 1-to-1, so I'll say it's a 1. For this time period, I have a 1 velocity. What's the slope of this horizontal line? Stop, insert question. It's 0. Right, from here to here, the velocity is 0. Now, what is happening here? What is the slope of this line right here? Stopping video. It's negative. So have a look. Your velocity right there is actually negative. My acceleration from here to here, if I'm moving constant velocity, it's actually 0. If I'm still, it's also 0. And if I'm moving at a constant velocity, again, it's 0. So what I did is I went ahead and drew these little lines that each represent the same period in time. So from here to here, same period of time to here to here, to here to here. I will tell you this. In order for you to go from moving constantly to stopping, there is some little instantaneous amount of acceleration, right? Because you can't just be moving and then stop like a black hole, like some gap in the time continuum. You can't just stop. And you do technically in the real world have to slightly slow down. What that does is it translates itself into a little acceleration blip down here. Okay, so I'm moving forward and I stop. I'm going to come back to that blip and what the direction of it is. I want to give you one more example. I'm moving down the highway pretty quick. And now, let's say all of a sudden I decide that this motorcycle drives up behind me and past me, and I want to keep up with the motorcycle. So I very quickly accelerate, and then the motorcycle kind of levels off. And then all of a sudden, I'm moving at this constant velocity, and then I hit the brakes really quick and move back at the same speed I was moving originally. My displacement from here to here should be the same pattern. It's going to look something like this. Now, where I quickly accelerate, I get this kind of curve, parabolic curve, right? So I run out of room. So then right here, I again go, so this goes up, then this goes this way. Now I slow down, okay, but I'm still moving forward. So now I just have a less sharp, and then the same thing here, another straight line. My displacement is constantly positive. because that makes sense, right? I'm in my car, I'm driving, I speed up to meet the motorcycle, and then I kind of cruise behind him. Then I see a policeman and I stop quick and keep going forward. But you know that by my description of the motion, you're still on the highway, you're still moving forward. Let's look at the acceleration here. From here to here, it's 0, because I'm constant velocity. I quickly accelerate here. What that is going to do, it's going to give me a little blip. What's the slope of this? It's a positive number, right? I'm going to get this little kind of blip in the acceleration here, or I'm going to get a blip like that. Then I'm not accelerating anymore as I move constant. All of a sudden I quickly slow down, and I'm going to get another kind of blip. And then from here to here I'm constant again, so no acceleration. Thinking about what we just said there, can you see what these little blips will look like here from here to here? Okay, constant velocity to 0 velocity. Oh, that's going to give me probably a little downward blip. Okay, 0 velocity to negative velocity. Okay, that's also going to give me a little downward blip. Question is, how do you know which way the blips go? Let's look at these two blocks. Same block, same representation, right? So what I've got is both blocks are moving at a constant velocity. All right, we're going to say constant velocity. Now I'm going to apply a force. In other words, I'm going to go ahead and give this one an acceleration in the positive direction. That means I'm going to accelerate it this way. I'm going to give this one an acceleration in the negative direction. That means it's going to accelerate that way. All right, this is case A. This is case B. I want you to answer here the questions on your Edpuzzle. I am hoping that you realized here this object is going to speed up. And in this situation, this one is going to slow down. I gave it a negative acceleration. When it had a positive velocity, it slows down. Okay? Positive and positive, it speeds up. I've added 2 more situations. This time, both of these blocks, I didn't draw all the forces. This time, each of these blocks are initially moving to the left in the negative. Sorry, that's a negative right there. If I tell you that this one speeds up, what is the sign of the acceleration? And if I tell you that this one slows down, what is the sign of the acceleration? You're going to put your answer in here. Are you surprised to learn that if it is speeding up, the acceleration is actually negative? And if it slows down, the acceleration is actually positive. Why? If the signs are the same, it speeds up. If the signs are opposite, it slows down. The signs are the same, it speeds up. The signs are opposite, it slows down. It is really that simple. Now, coming back to the picture with the blip. If you are moving positive and you speed up, that means you have a positive acceleration. If you are moving positive and you slow down, that means you have a negative acceleration. There you go. This is the first part of the review.